نبيت يختم ولالو شوهات سمعت فغري تلالو زارا نبيت الحكي سلي سربي عقوة سماكي زارنا عملي أي تسفر أي تقلم مكرت بأختي من ناي تسقان عاي بزلو كما قبل حنتو كابيتي تيانا حمامي أي تتسقل أي تمنو رقورت ويني تايما غير لنا نتا مسياسي وحمر دقاقني شوفوا فغري هبك زبلي تعرفي يساق ورملي شوفوا مبالي شوفوا لي زخبر عيني نومي ترى موزي سبر معي
Hello, my name is MaEd and I am mathematics teacher and tutor. So this is again part 9 as we have dealt some definitions of in the last week. Then today we are going to be see another additional examples from that what we have started. Then another example which says which one of the following are not continuous at a point a equals to pi? A, f of x equals to tan x. B, h of x equals to cot x. C, g of x equals to sec x. D, rx equals to cosec x. So of these listed functions, which one of those continuous at pi? Let's check it one by one. A, tan x in a sense, which is sine x over cos x. So we'll substitute pi, then sine pi over cos pi. Sine pi is automatically 0. Then cos pi is 1. Then the result is 0 over 1, which is equals to 0. Hence it is defined. Whereas it is continuous at a equals to pi, no matter for the second condition and third condition. It is defined, so you can check it by yourself. The second one, hx equals to cot x. Since cot x is the reciprocal of tan x, that's why cos x over sin x, cot x in its sense. That's why cos pi over sin pi. Cos pi is 1, but sin pi is 0. Then this is 1 over 0, hence it is undefined, or this number is the elements of the indeterminate values. Or as I have told you, the rat is over the head of the cat, which is impossible, or not defined, or cannot live, or cannot alive the rat over the head of the cat, which is undefined, hence whereas it is not continuous at a equals to pi. That's why this is not continuous at a equals to pi. C, g of x equals to sec x. Sec x in sense is reciprocal of the cos x, then 1 over cos x, then 1 over cos pi, 1 over 1, which is equals to 1, which is defined, it is automatically continuous at a equals to pi. D, rx equals to cosec x. Since cosec x is the reciprocal of sin x, then this is 1 over sin x, then 1 over sin x in sense sin pi, then 1 over sin pi in sense sin pi is 0. This is what you call 1 over 0, which is undefined again. Hence it is not continuous at a equals to pi. Therefore, let's turn back to the question. What it says, let's understand it. Which one of the following functions are not continuous at a point a equals to pi? That's why our answer is D and what you call for the cot x. Cot x and cosec x are not continuous at pi. So we can generalize like this. What it says the remark. hx equals to cot x and rx are not continuous at aid equals to n pi, where n is an integer, which means that not only they are continuous at pi, but also at 2 pi, at 3 pi, at 5 pi, and so on. In general, those two functions, cot x and cosec x, are not continuous for those of the values which is the multiple of pi, or in general n pi. Again, f of x equals to tan x and sec x are not continuous for those of, again, n pi over 2, or the odd multiples of pi over 2. So you have to be different. This is a special case. You have to be checked for the continuity for the special functions which are called trigonometric functions. Hello, how are you? My name is MaEd Selassie. As you know, we have continued from the chapter 1 still to the continuity. We have dealt last week again for the continuity at a point. Today we are going to see continuity on intervals such as closed interval or open interval, or continuity from the bounded from the lower and bounded from the above. So today we are going to be check whether a function is continuous on intervals. So let's see one by one. A function f of x is said to be continuous at a closed interval a and b if it's continuous for every point in the interval, including the endpoints a and b, which means that